The automotive world has always thrived on bold ideas, but not every breakthrough makes it across the finish line. Some engines looked unstoppable on paper, yet when the real test came, they fell apart and failed miserably. Take Volkswagen's G-Lader supercharger, which shredded metal every 20,000 miles, Oldsmobile's 5.7-liter diesel that warped heads and destroyed blocks, or Chrysler's 1963 Turbine car, which spun at an incredible 36,000 RPM, yet burned fuel like a rocket. These aren't just stories about bad engines. They're epic sagas of ambition meeting reality, often with spectacular results. Don't miss a single failure or breakthrough. Hit subscribe and join the ride. 20. Cadillac V8-6-4, 1981. The premature genius. Back in 1981, Cadillac rolled out the V8-6-4, an engine that sounded like it belonged in the future, producing 140 horsepower. The idea was genius. The engine could deactivate cylinders on the fly, running on 8, 6, or just 4 cylinders depending on your driving. The promise was huge. Better fuel efficiency without losing the V8 power everyone loved. On paper, it was the perfect solution for highway cruising, but the tech of the time wasn't ready. The electronics couldn't handle switching cylinders smoothly, and drivers experienced an engine that felt unpredictable and rough. One owner even described it as like being in a paint mixer. Most Cadillac owners had the system disabled by their dealers, leaving the car as just a normal V8. The cruel twist? By the 2000s, cylinder deactivation worked flawlessly in other cars. Cadillac's V8-6-4 wasn't wrong. It was just about 25 years ahead of its time. 19. Volkswagen G-Lader. Supercharger, the scroll of doom. In the mid-1980s, Volkswagen introduced the G-Lader, a supercharger that looked straight out of sci-fi. Its clever spiral design used interlocking scrolls to compress air, giving engines an instant boost with a unique whirring sound that fascinated or frustrated owners. On paper, it was perfect. Turbo-like power without turbo lag, smooth delivery, and impressive engineering flair. In practice, though, it was a disaster. The G-Lader required constant maintenance, sometimes as often as every 20,000 miles if pushed for extra power. Its delicate spiral scrolls wore down quickly, producing metal shavings that could ruin the engine. The materials of the time simply couldn't handle the heat, pressure, and friction involved. Even tiny errors in upkeep could trigger catastrophic failure. Essentially, the idea was ahead of its time. Brilliant in theory, but mechanically unreliable, leaving VW with a supercharger that became more infamous than iconic. In 1978, Oldsmobile tried to create a diesel V8 by simply tweaking its existing 5.7-liter gasoline engine. GM didn't build a diesel from the ground up. They raised compression, hardened a few parts, added diesel badges, and called it innovation. On paper, it sounded smart. In reality, it was a disaster. Diesel engines produce far higher pressures than gas engines, and the old V8 design couldn't cope. Cylinder heads warped and pulled away from the block, mixing oil with coolant and destroying the engine from the inside out. Despite repeated warnings from GM engineer Darrell Sand about broken crankshafts, leaking head gaskets, and failing fuel pumps, management ignored the risks. By the early 80s, lawsuits, warranty nightmares, and a ruined reputation turned the 5.7-liter diesel into a cautionary tale. Proof that a half-baked conversion from gas to diesel can be catastrophic. 17. Renault F8 Q 1.6. Diesel, the French disconnect. Renault's F8 Q 1.6-liter diesel engine made its debut in 1988, and on paper it looked like a practical, economical choice for European cars. Light, efficient, and seemingly well-suited for daily commuting, it promised decent fuel economy and enough power for small family cars. The engine's second generation, introduced in the early 1990s, however, quickly revealed its fatal flaw: cylinder head cracks. The issue wasn't obvious at first. Weak head casting, combined with poor cooling design, meant that under prolonged use or higher temperatures, the metal would warp. The result? Head gasket failures, coolant leaks, and overheating could damage pistons, valves, and sometimes even the engine block. Owners found themselves constantly topping off coolant and dealing with engines that needed premature replacement. In short, Renault's F8Q was a case of an engine perfectly designed for its intended environment in France, but completely unprepared for the rigors of real-world, high-mileage driving elsewhere. leaving the industry cautious about lightweight diesel designs. 16. Mazda Wankel rotary, RX-7, RX-8. The spinning sensation. Mazda's Wankel rotary engine first appeared in 1967 with the Cosmo Sport and later gained fame in the RX-7, 1978 to 2002, and RX-8, 2003 to 2012. Its design was revolutionary, compact, smooth, and capable of astonishing high revving performance. The engine's signature exhaust note became an instant fan favorite, and the rotary concept seemed like pure engineering poetry. But beneath the surface, serious problems lurked. The triangular rotors relied on tiny apex seals to maintain compression, and these seals wore out rapidly. The consequence? Severe compression loss, excessive oil consumption, and engines that required constant, meticulous maintenance. Even enthusiasts learned that longevity was limited. By the 2000s, stricter emissions regulations dealt the final blow. When Mazda ended production of the RX-8 in 2012, it marked the end of mass-produced rotary engines, cementing Wankel's reputation as both an icon and a cautionary tale in automotive engineering. 15. Chevrolet Vega aluminum engine, 1971 to 1977. The aluminum misadventure. When GM launched the Chevrolet Vega in 1971, the world was promised a lightweight, fuel-efficient engine that could compete with small imports. The idea? Revolutionary. An all-aluminum engine block meant lower weight, improved economy, and better performance. The reality? A disaster. GM's cost-cutting choices left the engine block without traditional iron cylinder liners, relying on a thin silicone coating to resist wear. That coating failed quickly under normal driving, scuffing cylinders, burning oil, and triggering frequent engine failures. The cooling system made things worse. A radiator too small for the engine's thermal load led to overheating, warped blocks, and blown head gaskets. By 1975, Vega engines were notorious for unreliability, high maintenance, and rust issues, leaving drivers frustrated and tarnishing GM's small car reputation. The Vega's aluminum engine remains a stark example of innovation gone wrong, proof that brilliant concepts can crumble without careful engineering and real-world testing. 14. Cadillac HT4100. The luxury disaster. When Cadillac rolled out the HT4100, the goal was ambitious: combine luxury with better fuel efficiency. On paper, it sounded like a win. The engine featured an aluminum block with iron heads, a combination that theoretically could cut weight while keeping strength. In practice, it was a ticking time bomb. Aluminum and iron expand at different rates when heated, which meant gaskets would fail, coolant would leak, and engines often ended up ruined entirely. Cadillac's attempts at damage control were almost comical. They issued a recall instructing dealers to drop stop-leak pellets into the cooling system. Imagine that. A luxury automaker essentially saying, "Our engine will leak, but here's some bubblegum-style fix." Despite the high hopes, the HT4100 became a cautionary tale, tarnishing Cadillac's reputation for reliability and showing that innovation without testing the fundamentals can turn even the most glamorous car into a mechanical nightmare. 13. Chrysler 2.2-liter turbo, the rod-knocking wonder. Chrysler introduced the 2.2-liter turbo in 1984 with a clear vision. Small cars, big thrills. The idea was compelling: a compact, fuel-efficient engine that could deliver sports car-like acceleration. But the reality was far from it. The engine's internals weren't built to handle the extra stress from forced induction. Rod bearings failed, connecting rods bent, and catastrophic engine destruction became common. Drivers quickly learned to fear the rod knock, a metallic tapping that signaled imminent failure. By the late 1980s, a mechanic could identify a failing 2.2-liter turbo just by listening in the parking lot. The underlying cause? A rush to market and cost-cutting measures, which meant thinner rods and insufficient lubrication passages. Instead of blending economy and performance, the 2.2-liter turbo ended up excelling at one thing: disappointment. 12. Subaru EA82 Turbo, 1984 to 1990. The Boxer's glass jaw. Subaru's EA82 engine was solid in its naturally aspirated form, a reliable flat-four. But when Subaru turbocharged it for models like the XT and Leon, problems started. The EA82T in the USA made 111 to 115 horsepower and 113 to 117 PS at 5,200 RPM. Sounds good on paper, but the engine bay was a mess of pipes, hoses, and intercoolers twisting like spaghetti. Every bend and joint was a potential failure point. The oil return system was poorly designed, relying on gravity, which often let oil pool in the turbo and caused failures. On top of that, valve cover and head gasket leaks were common. The EA82 block wasn't built for turbo pressure, leading to head gasket failures, piston wear, and a shorter lifespan. While the stock EA82 was reliable, the turbo version earned a reputation for fragility. Subaru learned tough lessons here, which later helped it build stronger, more durable engines. 11. Toyota 3 VZE V6, the camshaft killer. Toyota had built a reputation for crafting some of the most reliable engines on the planet. So when the 3 VZE V6 started giving problems in the late 80s and early 90s, it caught everyone off guard. Introduced in 1988, this engine powered vehicles like the 4Runner and Camry V6, promising smooth performance and solid long-term reliability. On paper, it looked great. 108 to 112 kilowatts at 4,800 RPM and 180 pound-feet of torque at 3,400 RPM. But under the hood, a serious flaw lurked: the camshaft. Heavy valve springs combined with limited lubrication channels put massive stress on the cam lobes. Over time, this led to rapid wear, scoring, and often total camshaft failure. It could destroy valves, rocker arms, and even the cylinder head. Early camshafts were also plagued by inconsistent metallurgy, making them even less durable. 10. Pontiac SD-455, the emissions victim. The Pontiac SD-455, introduced in 1973, was supposed to be the ultimate muscle car engine. It was essentially a detuned version of a high-performance racing motor, designed to deliver 310 horsepower at 5,000 RPM with 390 pound-feet, while still obeying the tightening U.S. emissions laws. That's where the trouble started. To pass emissions, Pontiac had to soften the camshaft, the part responsible for valve timing and lift. This compromise cut performance margins drastically, meaning even small manufacturing inconsistencies could make engines fail emissions tests. The stakes were high. Any engine that didn't meet the rules couldn't be sold. The result? Pontiac produced just 295 SD-455 engines, making it a rare collector's dream today. On paper, it had incredible potential, but the compromises required for emissions compliance hurt performance, reliability, and production numbers, turning this once promising powerhouse into a commercial flop. 9. Chrysler Turbine car, 1963, the jet-powered dream. In 1963, Chrysler unveiled something straight out of a sci-fi movie: the Turbine car. Instead of a standard piston engine, it ran on a gas turbine, promising futuristic perks: fewer moving parts, extreme durability, and the ability to burn almost anything from kerosene to tequila. The turbine core spun at up to 36,000 revolutions per minute, but output was 130 brake horsepower at the wheels. On paper, it seemed flawless, almost like a car from tomorrow. But reality hit hard. Starting the turbine was a delicate 8-step process, and mistakes could wreck the engine. Fuel economy was shockingly poor, and emissions were alarmingly high, particularly nitrogen oxides, at a time when regulators were tightening standards. The final nail in the coffin? All 47 prototypes eventually needed at least one engine replacement, giving the program a 100% major failure rate. Despite its vision, the Chrysler Turbine car was a commercial dead end, remembered more as a bold experiment than a practical solution. 8. Ford Nucleon, 1957, the atomic automobile. Back in 1957, Ford unveiled the Nucleon, a car straight out of a science fiction dream. The idea was bold: a tiny nuclear reactor under the hood, giving the car a mind-blowing 5,000-mile range without refueling. At a time when nuclear power symbolized the future, this was the ultimate statement of innovation. Designers even created a sleek, futuristic shape that screamed, "the car of tomorrow." But the dream quickly collided with reality. Radiation safety was the biggest hurdle. To protect passengers from deadly radiation, the car would have needed shielding as heavy as a tank. That alone would have made it impossible to drive. Even minor accidents could cause radioactive leaks, turning a fender bender into a disaster. And forget about engineering. Shrinking a nuclear reactor, controlling the heat, and preventing meltdowns was far beyond the technology of the 1950s. In the end, the Nucleon never got past a 3/8 scale concept model, leaving only a fantastical glimpse of what could have been. 7. GM Iron Duke 2.5-liter. The reluctant workhorse. The GM Iron Duke 2.5-liter is the definition of dependable, but not exciting. This inline-4 engine displaces 2.5 liters, 150.8 cubic inch, 2,471 cubic centimeters, featuring a 4.0-inch bore and a 3.0-inch stroke, and utilizes a simple overhead valve setup with 2 valves per cylinder. Mechanically, it was solid, but the problem wasn't strength. It was design compromises that caused headaches for owners. Its biggest flaw was the plastic timing gear. If a tooth broke, the engine would stop dead. In front-wheel drive cars, repairing it meant removing the entire engine, turning a tiny $50 component into a $2,000 nightmare. Add to that its uninspiring power, clunky vibration at higher RPMs, and the fact that it was shoehorned into cars meant for speed, and you see why it never earned love from drivers. The Iron Duke did its job reliably, but it failed to excite, proving that being tough isn't the same as being good. 6. Saturn 1.9 Twin Cam, the oil-burning graduate. Saturn attempted to showcase its 1.9-liter twin-cam engine, a symbol of GM's commitment to modern design and efficient production, producing 123 horsepower. On paper, it was promising. Lightweight, technologically advanced, and designed for smooth, economical driving. But in the real world, it became infamous for guzzling oil. Carbon buildup would make the piston ring stick, letting oil sneak into the combustion chamber. Drivers quickly learned to treat extra oil like spare cash. You never wanted to be caught without it. Ironically, the engine itself wasn't fundamentally broken. With attentive maintenance and the occasional spirited Italian tune-up to burn off carbon, these engines could last hundreds of thousands of miles. Yet the reputation stuck. The Saturn Twin Cam became a cautionary tale in design versus real-world performance, proof that even clever engineering can stumble if small but critical details are overlooked. 5. Lada camshaft overhead valve engines. Lada engines weren't inherently bad, they were just born into one of the most chaotic periods in Russian history. Between 1990 and 1996, the country's economy was in freefall and factories were barely surviving. In that environment, consistent quality control was nearly impossible. Metallurgy was often subpar, tolerances were inconsistent, and final assemblies reflected a kind of optimistic engineering. Some Ladas ran for decades, soldiering on despite these flaws, while others failed in ways that seemed downright bizarre. Engines would seize unexpectedly or components would wear in defiance of logic. This unpredictability became the brand's hallmark. For engineers and car enthusiasts alike, Lada engines were a stark example of how much potential could be squandered when economic turmoil collides with poor manufacturing, marking this era as one of the Soviet auto industry's most infamous struggles. 4. Steam engines for cars. Steam-powered cars weren't failures in the usual sense. They were just outpaced by gasoline engines. Vehicles like the Stanley Steamer and Doble were engineering marvels, delivering smooth, silent rides and insane torque that early internal combustion engines could only dream of. But steam came with a heavy price. These engines needed gasoline and water, produced massive, cumbersome vehicles, and demanded non-stop maintenance. Driving one wasn't as simple as turning a key. It required knowing boiler pressure, water levels, and fuel mixtures. Even starting the car could take 20 to 30 minutes, and keeping it running meant battling scale buildup and pressure leaks. When Henry Ford rolled out the assembly line, gasoline cars suddenly became cheap, reliable, and easy for anyone to drive. Steam cars, elegant as they were, couldn't compete. Their complexity and prep time made them impractical for the everyday driver, turning these magnificent machines into a fascinating but doomed chapter of automotive history. 3. Lexus 2.5 V6, the luxury letdown. When Lexus was building its reputation, it promised refined luxury, effortless acceleration, and smooth, commanding power. That's why the 2.5-liter V6 felt like such a disappointment. With just 204 horsepower, it was perfectly adequate for an economy car, but underwhelming for a luxury sedan where drivers expected to glide past traffic without thinking twice. The engine itself wasn't unreliable. It could last for years with proper care. The problem was entirely one of expectation. Drivers who hoped for quiet strength and silky acceleration instead found themselves constantly downshifting, just to maintain highway speeds. Under load, the engine sounded strained, robbing the driving experience of the effortless confidence Lexus was known for. In the luxury market, adequate simply isn't enough. Buyers don't just want a functional engine, they want one that feels commanding, smooth, and effortless. This underpowered V6, despite being well-engineered, clashed with Lexus's brand promise, tarnishing the company's carefully cultivated image. 2. GM Ecotec 2.2 pre-2006, the almost great engine. When GM introduced the early Ecotec 2.2, it seemed like a leap forward. Aluminum construction, dual overhead cams, and engineering that promised smooth, reliable performance made it look like GM was finally building a modern classic. On paper, it had everything an engine enthusiast could want. In reality, it stumbled. Timing chain tensioners often failed because oil wasn't reaching them properly, leading to early wear and that unmistakable rattling. Intake manifold gaskets were another weak spot, frequently leaking and causing vacuum issues, or even letting coolant mix where it shouldn't. Corrosion inside the engine and on external components didn't help either, cutting into longevity. By 2005, GM had addressed most of these issues, improving durability and reliability, but the early reputation was already tarnished. Today, the pre-2006 Ecotec is remembered as one of those engines that almost reached greatness but fell just short. 1. Ford Tempo HSC 2.3-liter. In the late 1980s, Ford rolled out the Tempo with its HSC 2.3-liter engine, aiming for a reliable, fuel-efficient four-cylinder that could power compact family cars. On paper, it seemed practical: modest displacement, simple overhead cam design, and enough torque for city driving. This engine produced 90 horsepower and 125 pound-feet of torque. It promised dependable everyday performance and low maintenance costs, appealing to budget-conscious buyers. In reality, the HSC 2.3-liter struggled from day one. Power was weak, leaving drivers frustrated on highways, while vibration at higher RPMs made long drives uncomfortable. Even worse, chronic transmission problems plagued the package, with clutches and gears often failing prematurely under normal use. Owners faced constant repairs and the engine never felt smooth or confident. By the mid-1990s, the HSC had earned a reputation as underpowered and troublesome, a stark contrast to Ford's ambitions. It wasn't that the idea was bad, just that the engineering and materials of the time couldn't deliver the dependable, lively experience drivers wanted. Which engines promised the future but ended up as legendary failures? From Cadillac's cylinder-switching V8-6-4 to Mazda's high-revving rotary, automotive history is packed with innovations that wowed on paper but stumbled in real life. These engines aimed for power, efficiency, or cutting-edge tech, but often delivered constant breakdowns, frustration, and disappointment instead. If you love uncovering these fascinating engineering misfires, make sure to subscribe for more deep dives into car history, triumphs, and disasters. And don't forget to comment below. Tell us which engine you think deserved a comeback or the one you'd never want to drive.